So good evening, everyone. Once again, we are into session 2 of day 2 of faculty development program on introduction to IoT and machine learning, essential skills for smart cities and mobility. Our second session for day 2, it is also taken by expert from industry who is working as at present manager in Walker Chandiok and has an experience of over 12 years in the area. He brings 12 years of experience in the technology domain and currently serves as the lead cloud solution architect at Walker Chandiok and the corporation. His expertise spans innovations in Azure, develops large language models and machine learning with a strong focus on advancing generative AI, and has significantly transformed collaborative platforms. In his previous roles, Mr. Akshay Kumar has played a key part in marquee government projects and held pivotal positions at KPMG, where he contributed to strategic technological advancements that redefined operational efficiencies and set new industry standards. So welcome once again, Mr. Akshay Kumar. He will be taking a session on machine learning, model building, and evaluation. He will take various steps to build, train, and evaluate machine learning models. So I hope you will be enjoying this second session too. And I will not be taking your much time. I'll handing this platform to Mr. Akshay Kumar for his presentation.
Thank you.
Platform is all yours.
Sure. I'm sharing my screen. So could you please tell me if it is visible or not?
Please share.
Is it visible?
Right now, it's not. We can only see you on the screen. You're only visible. Your screen is not visible.
Is it visible now?
Yes, sir.
Yes. It's visible. Go ahead.
Okay, so thank you, ma'am, for introducing me to the users over here. So as you already introduced, I'm Akshay Kumar. So I'm currently working in Walker Chandiok as a solution architect, and here currently I'm working on a lot on LLMs. And actually, right now, AI is talk of the town in any organization. So here, basically, we are working majorly on platforms like GPT and Cloud A and all those LLMs which are there. So what we are able to achieve here, that we are able to achieve some AI concepts over here, which are intent recognition, summarization, and we have included a lot of vector databases also in order to get the latest data out of those particular databases that we are having. So I majorly worked on cloud quite a lot. And in cloud also, we have worked on Azure and AWS and all those cloud platforms that are there. So in any of the organization nowadays, due to the introduction of this ChatGPT, we majorly focusing on AI only. And we have built those type of solutions where those solutions are able to understand the intent of the user, and accordingly, they are performing a lot of operations over there. So today I'm here to provide details about a particular model that I developed for this particular session only, where I'm leveraging linear regression for smarter urban mobility that is there. Okay, so in this particular project, I have used some of the Python libraries which are there, and with the help of those Python libraries, I'm able to achieve some type of predictions which are there. So I have leveraged some of the utilities also, which will be providing the feedback that how accurate is the results, and how things has been configured in this particular project. So I will be showing all these things right away. So I was having a call with the organizers of this particular session. So they told me that I should focus more on the code perspective. So in this particular session, I will be showing the code also, that how I was able to achieve this particular project that I created over here. So I will be presenting this. So this is the first slide I'm going to provide. So in this particular slide, I will be focusing more on the steps that are there in this particular solution. And this is a high-level solution architecture. Whenever we build a particular solution, in that solution, first we create this type of diagram where we will be having a particular end-to-end implementation configured over here, that yeah, we will be using these particular things over here, and how we are going to achieve it. I will be explaining these steps to you also, that how we have configured things over here, and how these particular modules will work together and provide us data in a proper formatted way. So for this particular session, I have focused on this predicting traffic levels in smart cities. Nowadays, traffic issue is quite heavy issue which is there. Means if we will have to commute from Noida to Gurgaon, then it will take you hardly 2 to 2.5 hours sometimes, due to the mismanagement of traffic. So what happens that if you are having some lights, traffic lights over there, those lights are not smart enough. So what they will do, that they will switch according to a particular frequency. They are not intelligent. So, but due to all these things, the traffic management is quite difficult to manage nowadays. So I think it's a right time that we should leverage machine learning over here and implement machine learning, so that those traffic lights and the other systems also can work in a proper way. So, and if there is a congestion or something like that, then the model should be able to communicate this to the higher authorities, that yeah, there is some traffic congestion there. So we should be precautious about that, and we should implement certain type of precautionary measures over there. So our model will predict the data, just like it will get the data from the IoT devices which are there. It will train on that data, and on the continuous integration with the with the IoT devices which are there, it will provide me insights that for this particular day there is a lot of traffic. So we should alert all the senior authorities which are there. So it will alert them, and it will provide the data accordingly to the end users also. So this is the model that I developed for this particular session. So here, these are the components which are there. One is the IoT sensors. So IoT sensors is the core of this particular model. So data and everything will be provided by those IoT sensors. I think there is technical, just like all the users which are there are technical, and they will be able to understand that each and every sensors provide data in a particular format. So, for example, if we will have to integrate one solution with another solution, then the integration and everything will happen through a particular JSON format only. So, what will happen, that I'm having a IoT sensor, and that IoT sensor will provide me some details. I will fetch it. That detail can be either in JSON format or CSV format or something like that. I will take that data, or this particular model will take that data, and it will modify that data and create that data in a particular format. And that format should be quite pure enough, so that our model can understand that data, and our model can train on that particular data. So in this particular diagram, we are having IoT sensors. So there are a lot of IoT sensors available right now. In the cameras that we are having, in that we are having those numbers available. That what is the traffic number which is there? What is the other parameters also? Those parameters also will be available through these sensors. Then after that, what we will do, that we will implement this data ingestion and storage layer. So that this data ingestion and storage layer means, in cloud solutions we are having these options, where we are having this cloud-based infrastructure such as AWS or Azure, aggregate and secure vast amount of incoming data streams components like Apache Kafka or dedicated ingestion pipelines ensure low latency, fault-tolerant data flow, supporting both real-time and batch processing. So what happens that when we are getting a lot of data from sensors, hello, is there any disturbance? Hello.
Sir, please put your presentation mode on, and the slides are not changing at all. It's
Yeah,
stuck.
I'm changing it. I'm just like explaining the solution, high-level solution architecture. Then after that, I will change it. But are you able to see the
But
diagram?
it's not in the presentation mode, so please do that.
Hello. Is it visible to others?
Yes, sir, visible.
No, sir, only the first slide is
Sir,
being displayed.
slide is visible, but it is not in presentation mode.
We are just getting to watch
Just
only the
please make
first
this in
It's only the
presentation mode,
first
full
slide that
screen.
No,
is
it
visible,
is in
Akshay.
presentation mode only. On my laptop, is it?
No, but it is here, it is not in presentation mode.
Sir, even if it is not in the presentation mode, you need to make the slide go further. We are stuck on the first one.
No. I'm on the second slide right now.
Could you please click on that so that we can see
Sir,
as well?
again
Let me
reshare
share
it.
it. Let
Reshare
me
the
share it.
screen, no problem.
Yeah.
Sir, I request you to share the entire screen, na? So, so it means
No, but
while sharing, share the entire screen. If you share the tab, this may happen.
is it visible now?
Yes, sir, visible. Now it's visible, sir.
So
Visible.
now you are able to see the high-level solution architecture which are there.
Yes, sir. Now it is in presentation mode.
Okay. Sure. So I explained about the data ingestion and storage. So in this particular step, we are going to cleanse the data that we are having and store it in a particular storage which will be there either in AWS or in cloud. Then after that, we will be having a machine learning pipeline core. And this particular pipeline is the heart of the system that I built over here. So in this particular core also, we are going to define the data more. And then after that, we are going to model the data and transform this data into predictive insights. And in this particular ML pipeline, there are a lot of algorithm and everything will work in this ML pipeline only. Then after that, we are going to this particular pre-processing part. In pre-processing part also, we cleanse, normalize, and engineer features to create a consistent and expressive data set. So all these activities is part of this particular data cleansing only. So I'm going to show the code also that how I'm achieving it. Then after that, we will be having a modeling part. In modeling, we will be having a robust linear regression model which predicts the future congestion levels and which is translating raw metrics into forward-looking intelligence. So in this model only, we will be building this particular feature, and we will be utilizing this particular model that we are having over here. And then after that, we will be having prediction, delivery, and visualization. It will happen in this particular predictions part. Then after that, in the predictions, we are going to have uh, dashboards, alerts, and APIs, which are allowing traffic authorities to commuters to respond proactively. So what will happen that we will provide the insights to the authorities with the help of APIs only, and through those APIs, authority will got alerted that there is some traffic issue at this particular point, and they should be able to address those issues over there. So this is the part of high-level solution architecture which is there. I will be explaining it more. I will be explaining IoT sensors and data ingestions and ML pipeline and everything over here. So this is the data inputs that we are having. So we are having this one of the data input as our day. In our day, we will be capturing the daily traffic patterns which is there. So in this particular part, we will be getting the data out of the sensors, and we are going to perform an activity. With the help of that activity, we are going to get this hour of the day. Then after that, we are going to get the vehicle count. We are going to get the temperatures. So all these parameters we are going to get from the sensors only which are there. So and we are going to purify this particular data, and we are going to present in a particular way. So that I will be explaining shortly to you, that how things happens. I will explain the code and everything. So in data sources also, we are having a lot of things over here. So I will explain that particular part in the next slide, which is there. So now we are having this particular slide now. Now this slide belongs to this pipeline stages. In pipeline stages, we are having pre-processing and cleansing. So in this particular part, well, what we will be doing, incoming data is often imperfect, missing readings, faulty sensor output, and abrupt spikes. So those sensors data, it is not clean, it is in a bad shape. So in this particular pre-processing state, what we will be doing, we will be smoothing that data, and we will be doing a lot of operations on that. Then after that, we are having model selection and training. So here for this particular module, we are using this decision tree for demonstrating that how things will work over here. Then after that, we are having this evaluation here also, where we will be assessing model performance, and we are having two parameters over there. With the help of those two parameters, we are going to define that how accurate our model is performing right now. So these are the things we are going to implement. Then in this next slide, we will be focusing on this pre-processing and model selection. So in this particular thing, I will be explaining you. These are the parameters, or these are the method we are going to use to refine the data which is there. In the pre-processing tools, we are having this standard scaler for continuous variables. I can showcase this to you also in code format also, but let me show my screen. Is my screen visible? Hello.
Not yet, sir.
Okay.
It is not visible.
Not it, sir.
Okay.
No, sir.
It is allowed. Yeah, is it visible now?
Yes, sir. It's
Yeah.
visible.
Yeah. So this is the model that I created over here. So what we are doing that if anybody is trying to implement this particular model, so these are the steps that I have defined over here. So these are the basic steps which will be useful, that if you want to build a model for this, then you will have to create a folder, then initialize the virtual environment, and activate that particular VNB which we created, or virtual environment that we created over there. Then we will have to install some of the particular packages which we are using over here with this command. Then after that, we are going to create a file called traffic congestion prediction.ipynv. And here what we are doing that actually we don't have any IoT data available right now. So what I'm doing that with the help of code only, I'm creating that particular data, and I'm going to show that data to you also over here. So this is the data I have collated through this code. So in this code, if you want to just like learn that how I have built it, then the explanation is here in this particular code only. That we are importing these libraries numpy and pandas which are there, and we are also using matplotlib and .pylot for data visualization. So for example, you are able to see the data over here. This data is being generated by this code only. Then after that, what happens that we are having this serial number over here, and we are having these hours. We are having this vehicle count over here, and we are having this temperature over here, and we are having this event and traffic level also. So what will happen that our model will train on this particular data. This data we can get from any of the sensors which are available over there. That sensor could be anything, just like camera or any other sensor which are available. So we will be getting these counts and everything from those sensors. So what I'm doing right now, that I'm building this particular data from code only. But yeah, if we are having IoT devices available, then we can get this data from those IoT sensors also. So this is the data I'm having, and in order to display it in a proper way, what I'm doing that I'm using this particular just like print command over here, and I'm showing the data in this particular format also. So in this, I'm having data pushed into a particular variable which is there. I'm having this data variable. In this data variable, I'm putting all the information which are there, and I'm showing it to you guys also, so that you will be able to understand that this type of data is there, where I will be having these columns and these data which are available over here, and this is the traffic level distribution also. So here this is the traffic level: high, medium, low, and these are the parameters which are there. So this is these two steps which are there. It is specific to visualization only and creating the data out of the code. These are the steps that we follow to get the data. So if I will be having a real-time IoT devices available, I can get this data from those devices, and we can prepare this data according to that. So these are the two steps which are there. Then after that, the major step that we are having, this is the step which we are using over here. We are using this sklearn, this particular library over here. So we are initializing the object over here. So if you can see that we are using this model selection pre-processing step and this compose step over here. We are initiating it, and then after that, the explanation of this particular code is defined here. So I can read it out to you guys also, and I will be sharing a link of Git in tomorrow's session where you can download this particular code and analyze that how things works from coding perspective also. So right now I told you that we are using classification task over here. So what we are doing that we are classifying these particular variable differently. Means here feature, these are the features and these are the variable that we are having over there here. One is R, one is vehicle count, one is temperature, and one is event. And the target that we are having over here is the traffic level, which we are going to calculate with the help of these particular variables, which we are having over here. So right now, what we are doing that we are classifying this data over here. So all the numeric things that we are having, R, vehicle, temperature, event, we are storing in this X variable, which is there, and all the data specific to all the data which is specific to which is not specific to numeric term, we are storing it in the Y variable. So this is the configuration that we have done. We have defined these variables over here. Then what we are doing that split the data set into training and testing sets. But we are doing that we have split this text into different variables now. So in XTrain, what we are doing that we are having features used to train the model. In XTest, feature used to evaluate the model's performance. In YTrain, actual traffic levels for the training set, and YTest is the actual traffic level for the testing set. So whenever we are training a particular model, we are having these XTrain, XTest, and YTrain and YTest. So whenever we are training a particular model, so 80% of the data or 60% of the data we use to train the model, and rest the data means 40% or 20% of the data we use to validate the model, that the data, if I'm sending to this particular model, is it yielding me any proper results or not. So this is how we are going to split the data over here. So it is also defined in this particular document. So here what we are doing that we are kind of splitting the data into 80 and 20%. So 80% of the data that we are using over here is for the training purposes, and 20% of the data we are using is for testing purposes. So here, this is these are the variables, and this is the method or this is the function that we are going to call. In this function, we are going to call these parameters which are there. So we are having this X variable, Y variable, and we are defining that what is the test size, what is the random state, and we are defining all these parameters over here. definition of these parameters and everything is defined in this particular comments only. So these comments are over here, that how to prepare the data set and how things are happening. Everything is
But
defined in
random is 42. Why, sir?
So I have taken it by
What does it
myself.
mean that random?
Means?
The random state, what does it mean, sir?
So the splits that we are doing, this random state, this like depends on this like whenever we are doing this split over there. So this random state helps in that. It is defined over here. Random state ensures reproducibility of the split, which we are doing over here.
Basically, actually, we are selecting states over here. So
Yes.
random state means that exactly after 46th entry, you are going to take one entry in the train and the second entry as the test. So
Yes.
this is what random state means over here.
Okay, sir. Thank you.
Then after that, we will be pre-processing, handling different data types. So actually here, I told you earlier also that we will be having this X train, X test, Y train, Y test. So we have defined the steps over here. It's essential to pre-process them appropriately before feeding them into a machine learning model. So numerical features are vehicle count, temperature. These features are continuous and may have different scales. We apply a standard scaler to standardize these features by removing the mean and scaling to unit variance, which helps in algorithm performing better. So this is why we have changed these values over here, that in X we have defined these values, and in Y we have defined these values. So this is how it is configured over here. Then after that, define the list of numerical and categorical feature name. So num feature, it is R, vehicle count and temperature, and cat feature which is there, it is event only. So now what we are doing, that we are initializing the transformer for numerical and categorical data. So we are just like doing this particular operation over here and this particular operation over here. So we are using this method. I think in the slide also I have shared that we are using these methods to pre-processing the data. So this is how the data will come to num transformer and cat transformer. And accordingly, what we are doing, that there is a variable preprocessor defined over here, and it is also doing the operations in this way, that there is a transformers variable defined. In this variable, we are going to provide data in this way, that this is the num and this is the category, means this is the number and this is the category. So we are going to store all these values in this preprocessor. Then after that, what I have done, that I have implemented this particular part where we will be having this model variable. In this model variable, we are going to store this pipeline which we built. So we have built a pipeline class which is there. In this class, we will be having the sequence as tuple. Then after that, we will be storing the memory and verbose that we are having. So all these things will store in this particular model that we created over here. Now, this is the just like we talk about model quite a lot. So this is the model variable which is there. Now, what happens that now right now this model is a runtime model which is there. So if we will have to store this model somewhere, then we will have to store it physically somewhere. So here the thing comes, that if we will have to store data of model anywhere, then how we can do that. So first of all, what we are doing in this particular process, which is the next step, which is over here, that this is the runtime model which we are having. Now we will have to access that how accurate is this model. So what we are doing, that we are checking the accuracy of this model. So all the training and everything happens in this particular step, where we will be having a preprocessor, we will be having a classifier, and there we will be having this random state and maximum depth also, which these parameters are there. I think I have explained each and everything in this code comment only, that how things will happen. So I think people will be able to understand that what we are doing with this data and everything over here. So now this fitting and everything will happen. Then after that, we will check the accuracy of this model. That what is the accuracy? So we are having this particular ACC variable, and we will be printing it. And there is this method available. So this method will just like get these values, and it will just like these are the y test variable which we defined over in this particular step, where we will be having x train x test, y train y test. So we will be having all those variables. So these variables now we are going to use in this test term, where we will be having x train and y train. So first it will fit the data using this model dot fit method, and after that it gonna use this particular y pred variable. In this y pred variable, we are going to store the values which we will get this from this model dot predict method which is there. So now we will we will print this particular ACC variable which is there. What it will do that it will print the data in this particular format. So this is the, when I will run this particular type, then it will show the accuracy over here. That this is the accuracy of the training that we have done for this particular model. So the 20% of data which we had left over here, it is tested with that particular data, and we are showing the accuracy over here. And there is a concept of RSME also, through which also we can get the accuracy of the model which we have built over here. So in this RMSE for regression, which is having lower value or which will be quite closer to zero, those values will be considered as good values. So here also in RMSE for regression also we are having values which are quite closer to zero, and it will work in this way. And there is another flow also which is there through TensorFlow. Also we can implement these models, and we can do a lot of operations over here. So, but yeah, I will not be focusing on that. So that's why I've commented it. And if anybody want to work on this, they can work on this particular part also. So now, we have created the model. This model is of runtime model right now, and it is not stored anywhere. Hello. Anybody is having any query? Hello. Hello. I'm audible?
Yes, sir, audible. I muted all.
Okay.
Thank you.
So now we will be runtime model. Now we will be storing this model in a PKL file. So for this particular scenario, we have used this job lib, which will convert my model, which is runtime model as of now. What it will do that it will get the data and it will store it in this particular format. Then after storing it in this particular format, this particular PKL file will be accessible in this. It will not be visible on the Visual Studio as of now, because it's in a binary format. And if you will have to deploy this particular PKL file, there are a lot of other features are available in Azure. So what we can do that if we will have to deploy this PKL format that we are having, we can deploy this model into Azure. And in Azure, we are having this machine learning studio. In this studio, we can deploy this particular PKL model over there, and there with the help of the training data, we can train this model, and the size of this model will get increased. So if I will go to the path of this. So right now it is having a 6 KB of data which is there. So if the size will increase, then in that case, what we will do that we will deploy this PKL model that we have, PKL format model that we are having. We will deploy it on Azure AI Search, which is a component over there. And what we can do that we can train this model. So the data that we are having right now, it is having 4-5 rows only. So what happens that when we are going to deploy this model onto a Azure platform, there the size can be handled in a particular way. so just like if we are having thousands, lakhs, and crores of data, in that case, the size of this PKL file that we are having will increase automatically, and it will be having a lot of size. So as I told you that currently we are working on the Azure OpenAI. Azure OpenAI is also having this issue that the size of the model which is there, it increase quite a bit, and it is quite difficult to manage the size of this particular PKL file. So for this, there is a distributed system which is implemented over there. So I think a lot of folks here are aware that what is technology and how we handle things. So we are having Kubernetes and those type of things available. With the help of those things, what we will be able to achieve, that we will be able to scale this particular model horizontally and vertically also. So there are two type of scaling that we implement in a deployment of a particular solution which is there. One is horizontal scaling and one is vertical scaling. So if we will have to implement a vertical scaling, that means on a particular server we are going to increase RAM, memory, and all those things over there. But if we will have to implement a horizontal scaling, then in that case, what we will have to do, that we will have to use different servers over there. So all these things will be handled by Azure by itself. What we'll have to do, that we will have to push this PKL file and push this PKL file onto the Azure. So in Azure, we are having this Azure concept where we can leverage both horizontal and vertical scaling both. Now we are having this CI/CD pipelines also available. So what we can do, that the code that we are having over here, now we will have to integrate this code onto a repository. So we are having this Git available over there. So if we will have to just like now I'm doing any change in the code, I'm changing something over here and changing this value. What this changing of the value will do, that it will be having some code version change there. So what will happen, that if we have to deploy this code now, so there will be change in the code. So my previous code and this code will not match. In that case, what we will have to do, we will have to manage different version of the code over there. So these all things will be handled by Git itself. So in Azure, we are having this concept of Azure DevOps. So in this Azure DevOps, we can manage different version of the code which is there. So in industry, we are having this particular source tool called source tree. In this source tree, I can explain you that in source tree, how we are managing the branches over here. So this is the one of the project in which we have utilized the Azure OpenAI API over here. So it is having different components over there. So we are having this feature branch. In feature branch, we are having different branches over here. So we are having this bot framework branch. We are having this OpenAI branch. We are having these utilities. So here we are maintaining the different version of the those branches over here. If you can see that here it is showing that these are the branches which are there for these components, and this is how we are managing the code also. So the code managing is the first part that I just want to show to you guys. Then after that, there is a part of deploying this code onto the Azure components which are there. Means there are AI search also. There is a component of managing models solely also. So those models can be handled by the Azure, and Azure is a very good platform to handle all the model and all those things over there. So this is the thing that we do for the to maintain the code. So we use this source tree tool. In this source tree tool, we are pushing the code, and we are defining the push that for this particular push, these are the changes which we are having. So what we are doing, that we can just like merge the changes onto the different branches also. Now we are having this UAT branch. In UAT branch, we are having these solutions over here. So if you have to merge the code from this particular branch to this particular UAT branch, that we can also do, and we can manage the code in a proper way in this way only. And now I will be showing you some of the slides that we have built for solutions that we have built in-house only. So there we are utilizing the chat GPT model over there. So this is the one of the solution that we build over here. This is called Ask Mobius. So we are having this solution. In this solution, we are providing a UI to the end user with the help of Microsoft Teams. In Microsoft Teams, we have built a bot. In that bot, we are utilizing this Azure bot framework. What we are doing that in this Azure bot framework, we are defining that if a user will input hi, then how should we respond to the end user. So all these activities will be performed by this Azure bot framework. And we are having the corresponding code to this particular bot framework, which is deployed on a particular web app. And in web app, we are having this bot framework deployed. Then after that, if we will have to make this bot AI enabled, what we have done that we have leveraged this web app. In this web app, we are having a Python orchestration code. So I will be showing you guys some of the components that we have implemented over here. So earlier, the code that I have shown to you, it is a Python notebook only. But here, this is the proper structure of the project which we implement in industry level. So here we are having proper structure. We are having these functions folder. We are having the environment variables. We are having the data utilities. In data utilities, we are defining classes and everything properly. So in this project, what we are doing that we are leveraging GPT-4 model and the GPT-4o model. And the concept that we discussed earlier, that we are going to implement intent recognition, we are going to implement summarization. So each and everything is happening in this code only. So this is the standard code which is there at the industry level. The code that I have shared with you earlier. In this code, this is a single PyNB file that I created. And in order to explain it to you guys, I have used this particular library and everything over here. So from industry perspective, this is how this is the flow which is there. So so for example, if we will have to get data from SharePoint, then how the flow will work. And in this project, we are using Azure AI Search as a database for vectorization. Means all the document that we are having, PDF document, Excel document, Word file document, we are storing them in Azure AI Search. In Azure AI Search, we are having this vector database available. In that vector database, we are storing the embeddings which we are creating for this PDF and Excel file, which are there. So I think we will be having one more session. In that session, I will be explaining to you guys that if we will have to use a smart decision making, means if we will have to implement a smart decision making from the model, then how we can leverage it, and how we can use it, and how we can show it to the end users also. So model will be able to understand. So for example, if I'm sending any prompt to the bot that I want to raise a timesheet, I want to create a timesheet. So in that case, bot will automatically understand my intent. It will go to the that particular API which is there. It will automatically access data from it. It will automatically show it to me. So human intervention will not be there. Each and everything will be done by that particular bot only. So those type of things we are able to achieve at the industry level. And this is the solution, means a fully working solution which we have implemented in our organization. And there are other solutions also which we have worked on, and I will be showing it to you in the next session also, that what are the other solutions on which we have worked on. So any questions specific to this from the audience? Hello, I'm audible?
Yes, sir. Sir, there are any kind of the free API for the chatbot?
No, these are the paid one only. But
Earlier,
yeah,
Chat GPT 1.0 provide the free API for enabling the chatbot, but right now I'm searching, I have not been
no,
find the any.
yes. So what you guys can do that you can create a free account over there on Azure. It will give you, I think, $200 or something like that credits there. So you can leverage those credits. You can create a source over there, and you can utilize it. It is available. So I can show it to you.
Because my one student are designing one application that are scraping the news from the different source and after that summarizing the news. and this
Yes.
news is assigned to the chatbot. And if anyone query to finding the news, so chatbot give the answer, but they are not be able to find the free API to enable the chatbot.
No,
So
no,
we
no. So,
expect error.
what happens? This I'm telling you that uh, earlier we were having services like Louis or something like that. So in those services, we are having that option where we were having a free tier available. So if we'll have to implement a proper solution, then you will have to go to the Azure and get this Azure OpenAI API, which is there. So in our solution also, we have distributed load onto different APIs. So we are having all these type of APIs available. So if you want to distribute the load, you can also do that. But yeah, if you have to get this particular API, you can take that $200 free credit and create this resource over here and utilize it. And again, if you want any help, I will share my LinkedIn profile also. You can take my help also. I can explain you things how things are working. The concept of
Okay.
and
Sir,
understanding.
but there are any kind of the limitation to create the Azure account. In the earlier, they are taking the credit card maybe.
Yeah, but that you will have to provide. But yeah, that those $200 will be there, so you can utilize those $200 only. Na? And there are options available to create the alerts also. So if your money is getting exhausted and you want to get an alert, then there is this cost management. In cost management, you can go over here and configure the cost management here and check that which resource took which amount of data which is there. So you can configure each and everything in this cost management. These are the cost alerts you can configure. So yeah, you can leverage it and use it. It will ask you for that particular $200. But yeah, now there are some other models also available. But yeah, each and every thing will ask you for a credit card. It's a must to have. And if you want to only leverage the bot framework, then at the backend, if you want to use Luis or something like that, that you can also use. So
Okay.
here we are having this. I can show it to you. So we're having this bot framework, bot services. You can leverage this bot service also to create a proper bot for you. But at the backend, you will have to use some intelligence which is there. So either you can create services like Luis or you can utilize Azure OpenAI. But Azure OpenAI is having a good response. The kind of intelligence it is having, it provides you data in a proper way. In tomorrow's call, I will be showing those things to you. So what it does that if you will ask it to provide data in a formatted format means there is a JSON format which is required to be the output of that particular model. Then it can provide data in that particular JSON format only. So those options are available through this Azure OpenAI API. And we are
Yes, yes. In a one application, we have to done like that. We have to convert it in the JSON file, and after that, we call from the JSON file because we are not be able to attend this chatbot application. So we have to make some arrangement like that.
yeah, but yeah, I think if you will go in a proper way, that will be good for you also. You will learn a lot of things. So it is good that if you can leverage those things also. These are the proper way of implementing a bot.
Yeah, of course. I will check that how the Azure help us.
Yeah. So now I think my screen is visible no? To you guys.
Yes, this is Visual Studio is visible.
Okay. Actually, what is happening that I am showing all this through a company laptop only. I think they have not allowed to share the entire window. So that's why it is showing only some of the components only. Let me share my screen and I will show you that what are the components that you can leverage. Yeah, so these are the services that you can leverage. Are you able to see? Hello.
Yes, yes, sir.
Okay. This is the Azure AI services, and these are the bot services which we're having. So this is how we are building the intelligent solutions in our organization. And with this particular model that we have built, so I can share the code with you guys. You can also check that how things were configured and how we can achieve a lot of things using this particular model class that we are having. So here we are having a particular PyNB file, and steps are also defined here properly. So now this particular file that we generated, we can deploy this file onto the Azure, and there also we can define that this is the input of the model and this is the output of the model. Accordingly, we can configure it in the Azure and train it. And if we want to get any insights out of it, that we can also get. Let me share my screen again. So the code steps are also defined over here. So any questions? Audience, I think there should be some type of question that how we are leveraging GPT and all those models. Hello, am I audible? Hello.
Yes.
Yes, sir. Audible, sir.
Okay.
Uh, you're done with your presentation, Mr. Akshay Kumar?
Yeah, I'm done with that. I think
Okay, okay.
there are
Any questions?
Excuse me, sir. If if in case there is if there is no question from the participant, so there are some participant sending WhatsApp messages to me. Some easy मतलब थोड़ा easy language में इनको इस topic के बारे में बता दें तो it would be very much better. Some of the participants are listening, please. In brief, please. Maybe in 10 to 5 minutes. Okay.
Okay, so they want to understand regarding the model, or they want to understand regarding this the solution that we built on ChatGPT.
I think both.
Okay.
Or sir, you can just in simple language you can explain about just starting from the IoT, means how the data is captured from the sensor, then how it will be go to gateway, what is the gateway, and how it will go to other steps like that. If something simple way.
Okay, so share the flow diagram. So Are you able to see the screen, guys? Hello.
Yes.
Yes. So what happens that these are the IoT sensors we are having. So all the data that is transmitted by IoT sensor, it got synced with this data ingestion and storage. So what will happen that all the data which is coming from IoT sensors, it is quite heavy data which is there. Means for a particular city, if we are having around about 100 to 200 cameras available, so the amount of data which will be sending by these IoT sensors, it will be sent in a just like the data will be quite large over there. So what we eventually do in between this IoT sensors and data ingestion, we introduce a particular layer over here, which is Kafka. What that Kafka does, that whenever we are sending the data from any sensor, first that data will be coming into this Kafka, which we have implemented over here. So Kafka is a service bus which we have implemented. So in that service bus, what happens that if each and everything is coming to the service bus, so data will be coming to that particular service bus. Then that service bus will send data to this particular module through a bus mechanism only. Means we will be having first in first out or last in first type of approach over there. So the load can be managed in a proper way. So in IoT sensors, if data is getting sent in JSON or something like that, so what that Kafka will do, that it will handle the load of that particular sensor, and to this particular module, it will not be having any issue with this particular integration with these two things. So the Kafka layer will be there. That layer will handle all the load, and this particular concept called service bus mechanism, which is there, that bus will be handling all the load, and it will be sending data to this particular data ingestion and storage service in a proper way. Then after that, if we will have to get the data of IoT sensors, then that data can be of any format. So it could be a JSON format, CSV format, or something else also, or a XML format. So in this particular module which I'm talking about, in that particular module, we can also leverage some data cleansing mechanism, which will be converting all this data into a single format only. There are services available in Azure. In Azure, we can leverage those services. Those services can take data from several sources and convert this data into a particular format only. Means if you have to convert the data into a JSON format, this layer can help in that also. So service bus is also quite good component which we can leverage in this particular solution. That Kafka solution can handle the load, and it will not be having any issues there in this data ingestion and storage layer. So those type of integration can also be done in a proper way. So this is how we are handling the load and everything of the solution. And then after that, the data that we are training for this particular model which is there. So when we have deployed this model onto Azure, now in this deployment of Azure model, if we will have to handle the traffic also, then there are mechanisms available to handle those type of traffics also. So for example, if I'm asking two type of question from the model, means I'm having a input. In that input, I'm asking that for this particular location, how's the traffic flow right now. So if I'm asking that question quite frequently to the to this model, then we can leverage any type of caching mechanism also over there. So we can have a caching mechanism through a lot of caching tools available. Those tools can, what will happen that this model will provide data to the end user. Then after that, that data will also be stored in that cache. So in that cache, we will be storing the frequently used data over there. And if that data will be coming from this particular model quite frequently to the end user, then that frequently used data can be used from that particular cache also. So this is how we are managing the load of this model also. So these are the ways through which we can manage the load on the model, and there are ways to handle load on the data and data ingestion and storage part also. So these are the things which we can leverage from the cloud. And I already
Sir, in this
yeah.
block diagram which you are displaying,
Yes.
After ML pipelining, there is one
Yeah.
route going to the pre-processing.
Yes.
Now, after pre-processing, there is nothing. So your block ends here. After pre-processing, where data will go?
No, there are some data which will be coming to this processing. But yeah, I think I have not mentioned the both arrows over here. It can go to this ML pipeline again and come to this model only. Those I think those arrows I didn't mention over here. So it can come to ML pipeline only, and then after that model can learn from this pre-processing data also. So this is how it will happen. Hello.
Yes, sir.
Yes.
Here, sir, you mentioned that some prediction will be there in the form of SMS or something. We can get the alerts also. But if I want, suppose we are getting the data from the traffic signals only. But now,
Okay.
if I want, instead of giving the alert, I want to control the on time or off time of the lights, green light or red light. How it can be done? Can it be done?
Yes, sir, it can be done. But we can do that. The data that we are getting from this particular model, there is decision making ability in the LLMs that we are having. So in this model, we don't have that functionality that it will automatically be switching the lights. But yeah, I already told you that there is a concept called intent recognition. So what will happen that we will get these alerts from this particular model. Then if you will have to perform any action on this, then that action can be performed by LLM. LLM means GPT-4 and all those things. So we have already achieved this particular functionality at our end, that if we will have to perform any action according to the input that we are getting from any of the source, that can be done with the help of LLMs which are there. So with the help of ChatGPT-4, we will be able to achieve it, and that action can also be performed. Or if any action, or for example, according to the inputs from this particular model, if we want to perform any action, that action can also be performed with the help of GPT-4. We are having this intent recognition functionality available as of now. It can be done.
Okay. Thank you, sir, for the explanation.
Sure. I think this part I was not showing to you, but yeah, here this is the input data with predictions. So this is R, this is vehicle count, this is temperature, event predicted, none, and then traffic level. Accordingly, but it is giving the output over here. And what I'm doing over here, that I'm putting these output into a CSV file also. So this CSV file is available in this format also. So we can convert this data into a JSON format, and that can be consumed by any of the end users also.
As a non-technical person, I will request to share some online resources to learn fundamentals of machine learning model building, key skills required to learn. Like I'm a beginner, from where do I start?
So actually, we'll have to get any subscription for LinkedIn Learning or something like that, some platform. In that platform, there are courses available. So if a user want to learn anything specific to machine learning and all, so there are courses available. And I think nowadays the definition of AI is this GPT-4 and all those type of models only. Those are the LLMs that we are having. So I explained in this particular scenario that here we are having linear regression implemented in the model that I have shared with you. But yeah, if we will have to build some type of AI solution, then we will have to utilize those LLMs only which are there. And if you want to learn those LLM, that if I will have to instruct LLM that you should have to perform this task. So there are some prompts available. So if you will write the prompts in a proper way, then that model will be able to understand. I think later on this will also happen, that I think coding will only happen for the machine learning and all those purposes only. I think from the UI perspective, you will write down to the model that create this type of page for me, the model will automatically just like provide you that page, and it can do things by its own only. I think web development can be done through the model only. So if you will have to leverage this prompt engineering or something like that, there are courses available. And for this portal also, in Microsoft Learning also, in Microsoft Learning we are having courses available. Those are free courses only. And I think over there some laymen also can get proper courses, that these are a training that they can attend and get a proper understanding that how things will work.
Okay.
Yeah, I think the development of AI is not solely dependent on code now. Through the prompt engineering also, there are a lot of things which can be achieved. So those courses are available. I will be sharing the courses in the chat also.
Okay.
There I will be explaining it.
So anyone else?
Okay, so I will be explaining something more also.
Okay.
Yeah, so if it is GPT-4, then how we can utilize the GPT-4? I can show the prompts and everything, how we have built in our solutions. I can show it to the users if they want. But yeah, let me present my screen. Is my screen visible? Hello.
It's visible.
Okay. So this is the prompt that we have written over here. So what it is doing, that we have defined a prompt. So we are not doing anything else. It's like our GPT-4 model is understanding from the prompt that I have shared over here. So for this particular model, I'm sending only this particular type of text to the model, that you are a highly knowledgeable and professional assistant designed to assist. This is the company name that is there. So your response must be based on solely on data available through the specified tools. So these type of prompts we have written over here. So all the tasks and everything will be performed according to these prompts only. So we will have to send this prompt, and the user will also send a query over there. So I can showcase this tool to the team.
One more question I have received on the WhatsApp from one of our participants. What is the purpose of splitting data into training, validation, and test sets?
Okay, so the purpose of this, that the data that we are having right now in any format, that data should be in a proper format only. And if it will be in chunks, then it is quite easier to manage that data. And if we will have to train the model, then that model can be trained properly with the help of those chunks only. So what we will do, that we will convert the data into chunks, and those chunks can be used to manage the training data, and used to manage the test the functionality properly. So what we are doing, that we are converting the data that we are having into chunks, and those chunks will be used for training and all those purposes. So that is the reason we use the chunks and all those things. I can show it to the user also. Let me share my screen. Okay. In the industry, these are the chunks that we create. Let me share it, the screen. So those chunks and everything, I'm going to show over here. So in industry, this is the AI search component which we have leveraged over here. So these are the indexes that we created. This is the vector database which we are utilizing over here. And if I'm searching any data, so for example, if I'm searching anything high over here, so now this is the data on which this model is trained on. So there is this chunk ID. This is the data which is there. So what we do that if we have to get data from multiple sources, then we can convert the data on which we are training this particular model into chunks, and with the help of that, we will be able to get a reference from multiple documents, and it will be easier to train that particular model also. So this is why we chunk that data. And in transform models also, we are having that encoding and decoding functionality available, where we will be converting data into tokens, and token from the token, my model will get trained, because the text data we are having, it is not that much accurate, and it is quite difficult to define the vectors and all those things. So each and everything can be defined on a digital format only. So that's why the data which is there, it will be converted into chunks, it will be converted into tokens. There are a lot of mechanisms to implement it which are available. So these are the reason we convert the data into chunks and all those things. So this is the industry example that I provided. This is the model. We are having this around about 40 GB of data which is there, and we are having 7,70,000 documents in this particular model which is there.
Okay. There's another question I have received on the WhatsApp. I don't know why I'm getting questions on WhatsApp. What are the common challenges encountered while building a machine learning model?
So actually, first challenge is this, that first we'll have to decide that which type of algorithm we are going to use. So I told you that in the model that we built over here, here we have utilized the linear regression. There are a lot of supervised learning, unsupervised learnings. There are a lot of mathematics in this. So linear regression is also a mathematical equation only, where we will be having data in a particular format, and we will have to train the model. Then what are the algorithm which we can implement over here? So each and every thing is required to be configured in a proper way. So first of all, the process of implementing a model, just like on the industry standard, happen in this way, that first of all, we will create the business requirement document which is there. Then in this business requirement document, the requirement and everything will be configured in a proper way. Then after that, from that particular requirements, we will analyze that what kind of algorithm we are going to use. In industry, we don't create a lot of models. There are a lot less model that we create over there. But yeah, what we are doing, that we are leveraging those LLMs which are there. Means either ChatGPT, OpenAI models which are there, means model 4.0 or those type of models we are leveraging. So after getting those models available on Azure, we are leveraging it and getting some operation performed on through those models only. So in industry, it is quite less that we train a model, but yeah, we are leveraging the LLM that are there. So I think it answered the query that this is how we are thinking that yeah, there will be a proper requirement document. There will be a proper method that yeah, if the problem is of this type, then use this particular algorithm, and if the user requirement is of this type, then use this particular model. So for example, I told you also that there are things implemented just like intent recognition, summarization, and all those things. It will be achieved through LLMs only. So if we'll have to get a specific data for a particular entity only. So in organizations, we are having tax related teams, audit related teams, and those teams are available over there. So if they want to do any operations on the data that they are having, they will be having a lot of data available. So according to that data, we define that what kind of algorithm we are going to use over here. So this is how it is defined. That BRD and everything we create to get a proper requirement from the users. Then accordingly we define that which model we are going to use.
Okay. So once you have constructed a model, how do we improvise the model performance? One more question I have received.
Okay, so I think I already explained this that there are data available. So it's a continuous process. So for example, I'm having 100 data now, but tomorrow I can have 200 rows available, 300 rows available. So on daily basis, we will train the model from the data set which is there. We will not use the data which is already there, but yeah, what we will do that we will be fetching the data which is there, the latest data which is there. We will be fetching it. We will be just like training the model on that particular data, and we will check the result of that particular training. So there are steps I defined. I think in those steps it is mentioned properly that if the accuracy will increase, then the numbers will also change. So accordingly, we check that from the training of this particular data, what are the changes happen on this particular model. So that can be done through this process only. That it's a continuous learning which is there. When model will be trained on the new data on daily basis. And just like the GPT-4, I think GPT-4 is, also works in that way. So if anybody is using a paid version of GPT, then they can see over there that the data that we are sending to the GPT is also learning from that data, and it is also sending the response to the end user. So it's like machine learning is totally dependent on the training that we do for that particular model.
Okay.
Sir, I have a question.
Okay.
Good evening, sir.
Yeah, good evening.
Sir, I have a question that when we trained a model for any data, we need to label that one firstly, right?
Yes.
So, sir, is not label any data and we can process it for any processing purposes, like is it a mandatory one, or like we can process any kind of data that is not labeled till now? Let's say
Yeah, your voice is breaking down, so I'm not able to.
let's an example, like we have a cats and dogs and we haven't that is a particular kind of picture that represent a cat, and that is a particular type of a picture that represents a dog. So suppose if I'm not putting any picture, I'm just adding the pictures, I'm not labeling it. So is that our model is quite enough so that they can identify to make a differentiate between this picture belongs to a cat or this picture belongs to a dog? Is it a mandatory one?
Yeah, it is a mandatory one right now. But yeah, I think the models like GPT-4 and all those things, we are having a attention mechanism configured over there. So that attention mechanism will decide that should we classify the data or not. I think the labeling is something related to classifying the data. That this data is specific to this, and this data is specific to a particular group or something like that.
But so how can we identify that, like we need to use here supervised learning or unsupervised learning or reinforcement? Suppose I'm training any data, I really don't know like which model suits it, like which kind of technique will be for that. So how can we identify that and so for that data set?
So actually, there are processes available. One of the processes manual leveling that we can do over there. But there is a semi-automated labeling also that we can do there. So model itself also provides this semi-automated labeling. Through the active learning frameworks where model requests human intervention for uncertain prediction, then in that case also semi-automated labeling can be utilized over there. So automated labeling, I think labeling can be of three types. One is manual labeling, one is semi-automated labeling, and one is automated labeling. So automated with the help of automated labeling, we can use the regular expressions and all those things over there, and we can leverage those regular expression to implement this automated labeling and label that data over there. That can be done through the regular expression that we are having. So, but yeah, if you want to use it in a proper way, the best way is to use the model only. So just like if I'm having GPT-4, send data to GPT-4 and ask it to label the data that you are having over there. So GPT-4 can also do that. We have leveraged it in our projects also, where we have asked the ChatGPT to convert our text into embeddings. So it helps us in a proper way, and the data is also quite good. I think the best way of labeling the data right now is doing it through ChatGPT only. But those APIs and everything should be available.
Okay, sir. Thank you.
Sure.
Anybody else? Any questions regarding this session? So, shall I assume that we can conclude the session now for day 2?
Yes.
I think so. So, very much thanks to Mr. Akshay Kumar for his insights into the topic of machine learning model building and evaluation. So it was very neatly explained and very comprehensively. He elaborated the steps to build, train, and evaluate machine learning models. So on behalf of team here at FTP, we thanks a lot to Mr. Akshay Kumar for his time and insights into the topic. We hope to be joined tomorrow at the same time for the day 3 session 2.